Hello everybody, welcome to section 2. This is going to be on metamorphic textures. So first things first, we have to talk about stress, which I'm sure you're all familiar with. It's not going to be that kind of stress. We're talking about stress like pressure. This is a sort of force being applied over some sort of surface. And in the case of rocks, that stress causes foliation. What is foliation? Definition is here, planar arrangement of textural features in a metamorphic rock. The easiest way to think about this is layering. So this, what we have here, is in the metamorphic rock, and this is the igneous counterpart, so cooked and uncooked up here. And if you looked at this, you would rightfully say that there's no sort of internal pattern or structure to this. It looks more or less dispersed, kind of random the way that the grains are, as opposed to this, where it's not quite like a sedimentary rock, but there's some very, very clear sort of layering to it, alternating light and dark bands. There's also, in metamorphic rocks, you see these veins. So not the dark necessarily here, but the little light colored things, just like the veins in your body. So rocks, when they're buried, carry with them these little cavities, these open spaces called pores, many of which are filled with fluids. I say fluid, this is water, plus all the little things, other chemical elements which the water might have inside of it. As the pressure increases, and the rock is buried further and further and further, those holes, the pores, get smaller as they get squeezed, and the fluid is squeezed out. As it gets squeezed out, it carries all of these little dissolved mineral pieces with it and forms these veins. So these veins are the paths of least resistance for the fluid, the little cracks in the rock as it was buried. And actually what we're looking at here with these are quartz. We're going to talk about a couple of different kinds of textures for metamorphic rocks: slaty cleavages, schistosity, mineral banding, and magmatic textures. First off, slaty cleavage. What does that mean? So this is slate, we're looking at here. In this case, we have parallel foliation, which is a fancy way of saying layering, of fine-grained, so really, really small, platy minerals. Minerals that they're shaped like plates, flat, very wide, a little thin, and they're oriented in the direction perpendicular to the direction of maximum stress, which is a long way of saying that if we squeeze the rock like this, then we're going to see all the minerals lay down in this direction because they're being squeezed this way. So these are the directions they can spread out in horizontally here. And we'll see this in slates and phyllites. An example of lower grade metamorphism. These are rare rocks, barely been cooked at all. So this is an outcrop of slate. You can see the layering really well up here, as well as the overall color look of it. It would be an option maybe to think that this is sedimentary because you see all the layers in it, but you would look closer at it, you would notice how hard it is, how dense. You would notice that it's not really composed of loosely put together mineral grains of any kind. It's hard rock, and you'd be able to figure out that it's not a sedimentary rock. This is commonly used in roofing for shingles, and also here for the first two numbers of the axis code, which are 8, 7, for pool tables. So this makes such a flat, smooth, even surface that you can actually lay felt on it and then play pool. Pool tables are so heavy, this is the reason. It's the slate. Schistosity is what we're looking at here. Notice how this thing is shiny. It's due to the layering of the minerals inside of it. So we have the layering due to parallel arrangement of platy mineral grains. We have these sort of flat mineral grains. They're stacked up in layers, and what we're seeing is they're so flat they're able to sort of reflect the light back at us. You can actually see in this one little garnets, and the ones that are harder to make out are going to be Quartz Starlight. This is example of intermediate grade metamorphism, so medium, like in a schist here. And this is what it looks like in outcrop. It's a little hard to tell the shininess here, so you'd have to look very, very closely maybe to tell what this is. We also see mineral banding, like in these two examples. So we have layering, where bands or lenses of granular minerals, things like quartz, which aren't really flat or platy the way that things like muscovite and biotite are. Alternating bands of these two. So we have these light areas, quartz and feldspar, and the dark areas, which might be biotites. This is well done rock, high-grade metamorphism, and it's common in rocks called gneiss, which is what we're looking at over here. And the same way, if you were out hiking and you saw this, you would say, this is nice. This is also nice over here. Finally, we have magmatic rocks. We have these over here. These are migmatites. These are metamorphic textures where part of the rock has melted, so you have, in a sense, what is sort of half igneous and half metamorphic rock. There's been some melting, not complete melting, but partial melting as part of the cooking process. So you have this mix of regions which very much look like they melted and then re-solidified, but also there is a sort of layering to this. This layer here, another layer on top of it, another layer on top of that, as in these pigmatites. And this is what it looks like in outcrop. This actually is in the Australian Mountains here. You can see a great example of it. Next section, we'll cover metamorphic rocks.